Hello, dear student. Today I will try to cover introduction to soil mechanics and its formation. First of all, we should know what is soil mechanics. What is the definition of soil mechanics? So, soil mechanics is defined as the branch of engineering science which enables an engineer to know theoretically or experimentally the behavior of soil under the action of loads, that is static or dynamic, gravitational forces, water, and temperature. Simply speaking, it is the knowledge of engineering science which deals with properties, behavior, and performance of soil as a construction material or foundation support. According to Carl Terzaghi, soil mechanics is the application of laws of hydraulics and mechanics to engineering problem dealing with sediments and other unconsolidated accumulations of solid particle produced by mechanical and chemical and disintegration of rocks. So what is the definition of soil? The term of soil, according to engineering point of view, is defined as the material by means of which and upon which engineers build their structures. The term of soil includes entire thickness of the earth crust from ground surface to bedrock, which is accessible and feasible for practical utilization as a foundation support or construction material. It is composed of loosely bound mineral particles of various sizes and shapes formed due to weathering of rocks. Okay, now formation of soil. Soil is generally formed by disintegration and decomposition, that is weathering of rocks through the action of physical or mechanical and the chemical agent which break them into smaller and smaller particle. Okay, you can see the picture of a formation of soil. These four type of picture you can see, and next you can see the weathering. You can see this picture topsoil, that is highly organic, and next you can see residual soil, that is oldest soil, and you can see completely weathered rock, then below highly weathered rock, mostly soil, and then moderately weathered rock, then slight slightly weathered rock. Now, types of soil. Soil types based on geological and engineering consideration. Number one, geological consideration. In geological consideration, the soil is deposited by the geological agent, that is glacier, wind, water, gravity, etc. Under the geological consideration, first is glacial soil. This type of soil is developed, transported, and deposited by the actions of glaciers. Glaciers means ice, big ice. Okay, these deposits consist of rock fragment, boulders, gravels, sands, silt, and clay in a various proportion, that is heterogeneous mixture of all sizes of particles. Okay, and next, residual soil. Soil is like that. This is a rock. Okay, after erosion, rock is flat. Okay, and this deposition is residual soil. Okay, this type of soil is found nearly flat rock surface where the weathering action has produced a soil with a little or no tendency to move. Residual soil also occur when the rate of weathering is higher than the rate of removal. Okay, now more important soil is alluvial soil. This soil transported and deposited by water is called alluvial soil. The following water is stream or river. Okay, alluvial soil. After that, this is also important soil, wind blown soil or aeolian soil. Okay, the soil transported by geological agent, that is wind, and subsequently deposited is known as wind blown soil or aeolian soil. Aeolian soil has two main type of, namely dune sand and loess. Now colloquial soil, the accumulation formed by the rock fragment and soil material resulting from the mechanical weathering of rocks is known as colloquial soil. Okay, this type of soil is formed more or less in situ or as a result of a transport transport by gravity over a short distance. Okay, next I will discuss engineering consideration. These type of soil based on engineering consideration depend on the particle size. Since the engineering property of soil markedly change with the change of particle size, different names are assigned to particular range of particle sizes. Okay, engineering consideration. So this is the chart. Very coarse soil, boulder size, cobble size, gravel size, boulder, cobble, gravel, sand size, silt size, and clay size. Okay, this is this is the ice sheet size. Okay, greater than 300 mm. If greater than 300 mm, that is boulder. Okay, 80 to 300 mm, that is cobble size, and 80 to 4.75 mm, that is gravel. Okay, 4.7 mm to 0.0425, sorry, 0.075, then sand size, and 0.0022 to 0.075 mm, that is seal size, and clay size is less than 0.002 mm. So we have completed the first chapter, that is introduction to soil mechanics and its formation. Thanks for watching.